Right, we're just going to do a few linear equations solving for the unknowns, starting with A. So firstly, we want to get the x by itself, so we want to bring this 7 across. Now because it's a positive 7, it comes across the equal sign as a negative. So x is equal to 15 minus 7. X equals 8. Moving on to B, we bring the negative 5 across to get f by itself. So the negative 5 needs to come across as a positive 5. So we get f equals 12 plus 5. So f equals 17. Okay, for C, we could do this a couple of different ways. We could bring the negative k across to be a positive k. And we could bring the 2 across this side, which is a positive 2, bring it over as a negative 2. So that would give us 10 minus 2 equals k. So k equals 8. The other way to do it is just to leave the negative k on the left, bring the 10 over. It's a positive 10, so it must come over as a negative. So you're left with negative k, don't forget the negative, equals 2 minus 10. So negative k equals negative 8. And then the negatives just simply cancel, or it's the same as dividing both sides by negative 1. So you're left with k equals 8. Now for D, let's again take the 5 across. It's a positive 5, bring it over as a negative. So we've got negative n is equal to 1 minus 5. So negative n, you must not forget the negative, is equal to negative 4. And then again, divide both sides by negative 1, or just cancel the negatives on both sides. So n equals 4. Now we want to get t by itself, so we bring the 3 across. Because it's a positive 3, it comes across as a negative. So t equals negative 6 minus 3. So t equals negative 9. Now going on to F and solving for B, the 9 is a positive again, it comes across as a negative. So negative B is equal to negative 11 minus 9. Negative B equals negative 20. And again, the negatives cancel both sides, or it's the same as dividing both sides by negative 1. So you're left with B equals 20. Moving on to some more equations to solve for X. Let's work on A. So this time we've got 5 multiplying by x. So we want to get the x by itself, so we bring the 5 across the equal sign, but to do that it needs to be dividing. So we get x is equal to 20 divided by 5. So 20 divided by 5, as you know, is 4, so x equals 4. Looking at part B now, we want to solve for S. So we want to bring this 3 across the equal sign. It's a multiply, so the 3 comes across, but it's got to be dividing. So we're left with S equals negative 12, divided by 3. So S equals negative 4. Don't forget that negative. Solving for C now. Again, we want to bring this 9 across. It needs to come across as a divide, so n equals 27 divided by 9, n is equal to 3. Now solving for D, we want to get h on its own, so the negative 6 needs to come across to the other side. Because the negative 6 is dividing, it must come over as a multiply. So h is equal to 5 times negative 6, h equals negative 30. Moving on to part E, we're solving for A, but at the moment A is dividing. So we need to get the A across this side, and it must come over as a multiply. So we'll just do it in stages. So 14 equals 2A. Now that's no different to saying 2A equals 14. Okay, now we want to bring this 2 over. It comes over as a divide because it's multiplying by the A. So you're left with A equals 14 divided by 2, A equals 7. Moving on to F. To get x by itself, we've got to go with the order of operands. So we've got to do the division first because the x is being divided by 6 and so is the 1. So let's bring the 6 across, and because it's dividing, it comes across as a multiply. So x plus 1 is equal to 2 times 6. X plus 1 equals 12. Now we can bring the 1 over. So the 1 is a plus, so it must come over as a minus. So x equals 12 minus 1. X equals 11. Alright, moving on to some more difficult linear equations. Looking at part A, solving for y. Now we've got to do the order of operands and order of brackets first again, so we can't get y on its own until we get rid of this 2. So the 2's got to come over, and because the 2's multiplying, it's got to come over as a divide. So we're left with y minus 1 is equal to 8 divided by 2. So y minus 1 equals 4. Now to get y on its own, the negative 1 must come over, but it comes over as a positive, so y is equal to 4 plus 1, y equals 5. Now looking at part B, again we can't work with what's inside the brackets until we get rid of this 8 at the front, so it's got to come over as a divide. So we're left with 2x plus 1 equals 24 divided by 8. 2x plus 1 equals 3. Now before we can get rid of the 2 that's in front of the x, we've got to bring this 1 across, and it comes over as a minus. So we've got 2x equals 3 minus 1, which equals 2. 2x equals 2. Now we can bring the 2 across as a divide. So we're left with x equals 2 divided by 2 equals 1. Okay, now with part C, there's a couple ways we could do it here. So the 4 is multiplying by the r plus 2 that's in brackets, and the 6 is dividing. So what we could do is we could either bring the 6 across to multiply and then work it, and then just work that out, or we can start with bringing the 4 across to divide. The other way to look at it is to divide both sides by 4. So we're left with r plus 2, still in brackets, all being divided by 6, equals 4 divided by 4, which equals 1. Now we can bring the 6 across to multiply. So we're left with r plus 2 is equal to 6. And then the 2 comes over, but it's a plus 2, so it comes over as a minus 2. So it gives you r equals 6 minus 2 equals 4. Now just to show you the same sum, if we instead work with the 6 first and bring it over to multiply. So 4r plus 2 is equal to 4 times 6, which equals 24. Now we bring the 4 across to divide. So r plus 2 is equal to 24 divided by 4, which equals 6. And r equals 6 minus 2 equals 4, which gives you the same answer. Alright, going on to part D. So we can't get m on its own until we bring this 3 across. The 3 is multiplying by what's in the brackets, so it's got to come across as a divide. So we're left with 5m minus 2 is equal to 24 divided by 3. So 5m minus 2 is equal to 8. Now we bring the 2 across. Because it's a negative, it comes across as a positive. So 5m equals 8 plus 2. 5m equals 10. And lastly, the 5 is multiplying by the m. So the 5 comes across to divide, to leave m equals 10 divided by 5, m equals 2. Right, working on part E. Now that's similar to part C, so we can't work with what's inside the brackets until we get rid of the 2 and the 4 to the other side. Another way of looking at it, rather than doing the 2 and 4 separately like we did with the 4 and 6 in part C, and we could have done this with part C as well, is to recognise that 2 on 4 is the same as 1 on 2. So it's just a fraction with its simplest form. And then that way you're already eliminated one of the problems, and then you can just write out, you can bring the 2 across to multiply, and you're left with a minus 3 equals 6 times 2. A minus 3 equals 12. And then you bring the negative 3 across and it comes across as a positive. So a equals 12 plus 3, a equals 15. Alright, for part F, again we can't work with what's inside the brackets until we get rid of this 3 on the other side. So 3 is multiplying, it must come across the equal sign as a divide. So we're left with 4x minus 5 is equal to 33 divided by 3. 4x minus 5 equals 11. Now we bring the constant over, so negative 5 comes across as a positive. So we've got 4x equals 11 plus 5. 4x is equal to 16. And lastly, the 4 is multiplying, it comes across to divide. So we've got x equals 16 divided by 4, which gives x equals 4. Now I didn't mention earlier, the good thing about algebra is that when you get the answer, all you need to do is put it back in the original equation and see if you get the same as what's on the other side of the equal sign. So you can always know if you've made a mistake and you can fix it in an exam. Alright, these problems are a little bit more complex now. So working on A, we want to get the y's on one side and the constants on another. So because 5 is larger than 3 and it's a negative, I'm going to bring the 5 across this side to be a positive 5. And I'm going to bring this negative 14 across to be a positive. So we've got 10 plus 14 is equal to 5y plus 3y. So we've got 24 is equal to, and we can add the y's together, so it's 8y. It's the same as writing 8y equals 24. Alright, now we can divide by 8 to get y on its own. So y is equal to 24 divided by 8, y is equal to 3. Okay, working on B, firstly we're going to expand each of the brackets out so we can get the C values separate to the constants. So 6 times C on this side and 6 times 2. And then on this side 18 times C and 18 times 2. So we've got 6C plus 2 6's are 12 is equal to 18C minus 18 times 2, which is 36. Now this value is larger than this value, so we're going to bring the 6 across as a minus 6C, and we'll bring this negative 36 across as a positive. So we're left with 12 plus 36 is equal to 18C minus 6C. So that leaves us with 48 on this side and 12C on that side. It's the same as saying 12C equals 48. Now bringing the 12 over to divide, we're left with C equals 4. Now lastly, working on part C, again we're going to expand these brackets. So 5 times 1, 5 times negative 3, negative 2 times 10, and negative 2 times negative y. Alright, so we'll work through that first. So 5 ones are 5. 5 times negative 3 is negative 15y. Now minus 2 times 10, we've got minus 20. Minus 2 times negative y. Now remember, negative times negative is a positive, so that gives us positive 2y. And then finally that equals negative 16y. So let's add the constants on this side together separately and add the y's separately. So 5 minus 20 is negative 15. Negative 15y plus 2 is negative 13y. And that equals negative 16y. Alright, bringing this negative 16 across as a positive 16 and bring that negative 15 over as a positive 15, we're left with 16y minus 13y is equal to 15. So 16 minus 13 is the same as 3y equals 15, and y equals 5 because we've brought the 3 over to divide. Alright, working on the last set of problems. Problem A, we want to get A by itself, so we need to start by bringing the 5 across. It's a positive, so it comes across as a negative. So 3a equals 14 minus 5. 3a is equal to 9. Now the 3 is multiplying, bring it over as a divide. To get A by itself equals 9 divided by 3. A equals 3. Right, for part B, let's bring the 2 across. It's a positive 2, so it comes across as a minus. So negative 3k is equal to 17 minus 2. Negative 3k is equal to 15. Now to get k by itself, we want to divide by negative 3 because the negative 3 is multiplying. So k is equal to 15 divided by negative 3. K is equal to negative 5. Alright, looking at problem C, let's take the negative 3x as a positive 3x. So we've got 4 equals 5x plus 3x minus 12. Now we bring the 12 across as a positive. So we've got 4 plus 12 is equal to 5x plus 3x. So now we can sum the like for like. So we've got 4 plus 12 is 16 is equal to 5x plus 3x equals 8x. Same as saying 8x equals 16. Now bringing the 8x to divide, we're left with x equals 16 divided by 8, which gives us x equals 2.